Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Electronic Flight Instrument System. In this module, we are going to study about the introduction, unit of the system, and EFIS. Have a look at this figure of the Electronic Flight Instrument System. Introduction. As far as the pure basic functions and number of display units are concerned, this system, which is generally referred to as EFIS, may be considered as being similar to the types of flight director systems. However, since it is fully integrated with digital computer-based navigation systems, utilizes color CRT types of ADI and HSI, then it is far more sophisticated not only in the terms of physical construction but also in the extent to which it can be present attitude and navigational data to the flight crew of an aircraft. Units of a system. As in the case of conventional flight director system, 296 EFIS installation is made up of the left, that is captain, and right, that of first officer system. Each system in turn is comprised of two display units, an electronic director indicator EADI and an electronic horizontal situation indicator EHSI, a control panel, a symbol generator SG, and a remote light sensor unit. A third center SQ is also incorporated so that its drive signals may be switched to either to the left or right display units in the event of failure of corresponding SGs. A symbol generator SG is a device that receives the data from the airframe sensor and serves as television transmitting station by processing the data for appropriate viewing. The signal switching is accomplished within the left and the right SGs using electromechanical relays powered from an aircraft's DC power supply via pilot control switches. The interface between EFIS units, data buses, and other system. The amplifiers for both the beams each consists of two-stage preamplifier and a power amplifier. Both amplifiers use two supply units, 15-volt DC and 28-volt DC. The former is used for effecting most of the stroke scanning or writing, while the latter is used for repositioning and raster scanning. This chart shows the table for the symbol generator card functions. In a typical system, 6 colors are assigned for the display of the many symbols, failure annunciators, messages, and other alphanumeric information and are as follows. White, display of the present situation information. Green, display of the present situation information where the contrast with white symbols is required or for the data having a lower priority than white symbols. Magenta, all flight to information such as the flight director commands, deviation pointers, and active flight path lines. Cyan, sky shading on the EADI and for the low priority information such as non-active flight plan map. Yellow, round shading on the EADI caution information display such as failure warning flap, limit and alert annunciator fault messages. Red, for the display of the heaviest precipitation levels as the weather radar. This table shows the control panel switch functions. Symbol generator SGs. These provide the analog, discrete, and digital signal interfaces between an aircraft system, the display units, and the control panel, and they perform symbol generation, system monitoring, power control, and the main control functions of the EFIS overall. The control panel is provided for each system. The switches are grouped for the use of controlling the displays of the respective EADI and EHSI units. Remote light sensor. This is a photodiode device that responds to flight deck ambient light condition and automatically adjusts the brightness of the CRT display to a compatible level. Display presentations. The EADI displays traditional pitch and roll attitude indication against a raster scanned background. The upper half is cyan and other lower half is in yellow. Director commands localizer and glide slope deviation, selected airspeed, ground speed, AFCS and auto throttle system modes, radio altitude and decision height. Radio altitude is digitally displayed and when the aircraft is between 2500 and 1000 feet above ground level. 1000 feet, the display automatically changes to a wide circular scale calibrated in increments of 100 feet, and the selected decision height is then displayed as magenta colored marker on the outer scale. At a selected decision height plus 50 feet, an oral alert chimes sound at an increasing rate until the decision height is reached. At the decision height, the circular scale changes from white to amber and marker changes from magenta to amber. Both the scale and marker also flash for several seconds. This figure shows the EADI display. Display presentations. The EHSI presents a selectable dynamic color display of the flight progress and plan view orientation. Four principal display modes may be selected on the control panel: MAP, PLAN, ILS, and VOR. In the PLAN mode, a static map background with an active route data oriented to north is displayed in the lower part of the HSI display, together with the display of track and heading information. Failure annunciation. Failure of data signals from such system as the ILS and radio altimeter are displayed on each EADI and EHSI in the form of yellow flags painted at specific matrix location on their CRT screen. In the plan mode, a static map background with active route data oriented to true north is displayed in the lower part of HSI display together with the display of track and heading information. Display of air data. In a number of EFIS applications, the display of such as air data as altitude, airspeed, and vertical speed is provided in a conventional manner. That is, separate indicators servo-operated from ADCs are mounted adjacent to the EFIS display units in the basic T arrangement.